Hi guys, how are you? I hope you will be fine. Well, sorry for the big delay of the absence. As you can see, I was in health with health problems, so I can record. Now I'm good. I'm great. So I'm gonna continue with the topics. S- Um, the methodology for the next video will be 1 week in Spanish and the next video in English. This is some topics for the next weeks. Well, this is in Spanish for our Spanish speakers. I have one video that I couldn't finish in the last part. That is the compressor energy consumption calculation. So now let's start with this. Uh, this is that sample. So our first information that we should need is our plant information. For example, in this case, I'm consider just 26 days by a year and 18 hours of working hour. Oh, sorry. Uh, the capacity of our compressor in cubic feet per meter, 269. This is the result of remember the last video. Sorry. Yes, about the compressor sizing. Then, well, I don't have the information in dollar. I have soles, that is the device of my country. So it's the same, just you change soles by dollars. So, well, in this case is soles per kilowatt 0.33. Then we need the compressor information. Is well, the brand is Schuler. The model that we select is the 45 plus. The power is 54.1. Well, in this case, I know the price in soles, so you should. That's the reason why I put the change, by dollars in soles. So, remember the model we selected model in here, the compressor 45 class. Then we have, how can I say it? Sorry. Oh yes, okay. In the market we have four different technologies for compressors. So we have the load and unload, that is a common. We have the modulate, the variable speed control, and the variable displacement. So I estimate the modulate, variable speed, and variable displacement prices since this. So sorry. I'm assume this is my start number. It modulate. So for load and unload, I just consider 15 $15 less, and then I start just to plus, plus 15, sorry, $5,000 plus here. Well, in this case is $10 if we take the moral lead. So how can we, oh sorry, this is in Spanish, I'm so sorry. How can we are gonna start for calculate our consumption for different type of technology in the compressor? Let's start with load and unload. First we are gonna analyze the compressor performance by plant demand and power curve. The information of working hours, annual working hours, is very important on this power. Remember that the power of we have is the first or principal motor, that is 60 horsepower, but in reality that's not true. Remember that, I don't know if I have here. No, I don't have it. No, remember that we should the compressors have different electronic systems, electricity system that are about the refrigerant system. So that's more that motor. So we should have the information about the total energy consumption that we have, the total power that we have for our machine. This is in Spanish, but we should include all the motors for our compressor. So in the finishing the video, I'm gonna show you where I find this information. It's in the data sheet. This information is in the data sheet. So that's where you can find it in Gaji. So I assume this percentage in time, 10 percentage, 70 and 20. What does it mean? That the 10 percentage of all that working uh, all the working hours represent that you are gonna work in your full capacity, something like this. Just the 10% of the time you are in the full 100 capacity. The 70% of the time you are using the compressor or the machine just in the 80 capacity, the normal work, full work, and the 20 time of that time of your working hour you're gonna use in the machine in the 60%. Could be maybe when you is lunch time, or your dinner maybe. So that's the reason. It's just an example. So the power by the curve is 197, 92. Where I find this? This is the picture of that curve for load and unload. You can find this for that improving compressor system performance. So now you just search that curve here. Here. What does it mean? We have 100 percentage, capacity and time. Capacity 100, 80, 70, 60, So 100, you're gonna just trace a line is here, vertical line and horizontal line. So you should mean the percentage input is 100%. So what does it mean? In the just the 10% of the time you are using the 100 percentage of capacity of your compressor. What does it mean? That you are using the 100 power of your compressor. Then for the 70 percentage of your time you're using your 80% of your compressor capacity. So that's something that I'm estimate could be different for your plant or your case. So for this case, the 80%, you're gonna trace a vertical line. For in this case, we are using the common time that is 3 gallon per cubic per meter, and then you cross a line just like here. You're gonna estimate I put 97, could be less, could be more, and then it's the same for 60. Just try here, then it could be 90, 92, 90, 90, I don't know. So that's the reason why I put this. Then you just calculate if we have annual working hours of that number of 5,616, you just then the 10% of that working hours, the 70 and the 20. What does it mean? If you have a power of 54.1 kilowatt, what does it mean? This is the 100% that power, your 97 of that power, and your 92 percentage of that power. Then you just gonna multiply to have your consumption of kilowatt per year, and then you just gonna plus or sum all these results. So you're gonna have, how can I read this number? Sorry, I don't know how to say that number in English. I'm learning. So that's the methodology of how to calculate your consumption if, for using the power, using the curve of the power by curve. This is for load and unload. You have three more. It's the same. I'm using the same. The difference will be where it's gonna be, where this gonna be changed. Different. Sorry. Here, as you can see, for modulate technology, we have a different curve. It's totally different. For variable speed control, we have this. It's a different curve. For variable displacement, it's different. All of this is different. So we are gonna have different consumption in annual consumption for all this type of technology. As you can see, for modulate is 195.89. For variable speed is 180 and 60, so it's less. And then 185 and 70 for variable displacement. We are gonna have all this consumption, but there's another something that we should consider. So if we have the kilowatt per year in a standard condition, this number is the same of here. It's the same. We have, remember that for load and load compressor, we have that standard, for it's the most common implants of pressure drop of 10 psi. Just for, what does it mean? That in 100 psi the compressor start loading, and then in 110 stopped, so that start unloaded. So what the rule tell us, and this is in the page 24. For that case, a rule of thumb for system in 100 pounds per square inch gauge or psi range, for every 2 pounds per square inch increase in discharge pressure, energy consumption will increase by approximately 1% at full output flow. So that's the important thing. So what does it mean? If we have a pressure drop of 10 psi, so what we have what does it mean? That 5 times 2 psi, so that's almost a 5%. So we have, I'm considering this, you should have 5 times that percentage that they tell us, and consider a little bit more. So because we have a different part that is assuming the combined effect of for energy consumption, that assume the legs another by the demand. So I'm using the less number, so that's the reason why I put 5 times 0.0 or 16%. Then we have a new total kilowatt per the year. This is just for load and unload, and then so that's our real consumption for the year. So if we should, this is energy, kilowatt per year. Well, no, it's not energy, it's just your consumption. Then if you want to know how this is in soles per year, so you should multiply by, in this case, soles per kilowatt 0.33. So you have your total, just multiply. In 10 years or working hours, this will be the number. So it is the same for, so this case of pressure delta or your pressure drop of 10 psi just work for load and unload, because in modulate variable speed control and variable displacement, this condition doesn't work. This condition doesn't work, so that's the reason why in this case is 0. We don't have it. We don't have it. This just that condition is just for load and unload technology. For modulate, variable speed control and variable displacement, it doesn't work. So our energy consumption in the year will be the same for the year. This is work from the case of 3. And the same if we want to know in soles how much is it, and in 10 years will be the same. And we are just multiply your total year for 0.03. Then I'm so sorry, this is still in Spanish. So this is the cost or the price if you are considered that your overhaul maintenance. This is a special condition because for I don't know how is in, I think in Atlas Copco this is your overhaul is in the night or your 10 years. For Schuler, that brand recommended you need an overhaul in the year 10. But assuming that because we select a Schuler, so you should analyze the Schuler. Normally, another brands tell you that you need overhaul maintenance in the every 3 years. So that's the reason why approximately I'm consider just the 33% of your total price for your overhaul. I'm just estimate because I'm using the total price. I'm just estimate this. The 33% of your total price will be the cost of the overhaul maintenance, and just an estimate. That's the reason why that's same. So the total cost of the asset in the 10 years will be your energy consumption plus your overhauls maintenance. For modulate, it will be the same. So remember, what's the reason why this case is 0? Because the overhaul is in the year 10. So we are not gonna have any overhauls in that time. So we don't have to spend more money. So we are gonna just plus this. Remember that we are applying the price just because this is the total cost of the asset in 10 years. The same for VSD 0, and the same for variable displacement 0 because we don't have overhaul. So if we wanna select what compressor should I buy, so you're gonna I want the VSD, the variable speed control, because I have less consumption. I have very less consumption. Just look the load and unload, look the modulate, look the velocity speed control, look the variable displacement. So I select the velocity, the variable speed. So, but we have some qualities about that technology, and that's for you, that's an extra information. For in the case VSD is dust and they're sensitive, it's expensive to fix. If they're a failure, the equipment stops, and this is available since 20 horsepower. In the case of variable displacement, is dust and dirt resistant, easy to repair if you have a good technician. And if there is a failure, the equipment stop variable displacement but start working in modulate function. And this is the variable since 75 horsepower. This is an information that you're gonna find in the market. So you said, I want this, yes, but remember you select a compressor of 60 horsepower, so you can buy this variable displacement, and you have if you are not maybe for drugs plant, or I don't know, something like food. So you don't need this the velocity speed control compressor. So that's the reason why the correct selection will be the modulate, because you have your limit of the horsepower, 60 horsepower, and you, if you are another type of plant, maybe an industrial of manufacturing, so this will be great for you. So thanks, guy. I hope you have a nice day. That next week we are gonna continue with the video about, remember that I think I put here, yes, about the select for, I don't know is correct, flat or plain belt, I don't know how to say it. Then the V belt and the rubber timing belt with real cases, all with real cases, just not that theory. See, I'm gonna show you or teach you how to use that information for real life. Then well, this we've hopefully finished. Yes, because sorry for that time that I was upset. I okay, yes. So we actually now finish with all that information. If you want if you want this document, you can just load free of on the internet. You just Google it, and well, this is the name. And if you wanted to send you by email or I don't know, you just keep it in the comments. So thank guys. Have a nice day. Thanks for your time. Thanks for your tolerance and passion. And if you, also if you listen some weird in my English, please, I'm just trying to do my best. If you can help me, I really appreciate it. Thanks, guys. Have a nice day.